Hi, good morning, everyone. Yes, this is Mr. Chua speaking to you guys again through the YouTube platform because unfortunately I can't make it to school again today. But not to worry, we are going to still have a lesson. We're going to continue our A Math lesson today as we will be applying what we have learned from yesterday's lesson on some of the contextual word problems today. Okay, so just a very quick recap. In the previous session, we actually learned about the first and the second derivative test. All right, and if you guys can recall, the first derivative test will require you to construct a table, and then from the shape of our tangent lines, deduce whether it is a maximum point or a minimum point or a point of inflection. Okay, for example, over here, I have a minimum point. If a case like this, I have a maximum point. And last but not least, sometimes you may get a case like this or a case like this. Sorry, which means to say it's a point of inflection. All right, so that's the beauty of the first derivative test, where you will definitely be able to find out whether the point is of a minimal, maximal, or point of inflection. Then I also introduced the second derivative test to you guys, where you're supposed to find the differentiation of dy dx, and that gives us the 2y over dx squared. And then you're supposed to sub in the specific x value, the stationary x value, to find the 2y over dx squared. And we know that if the 2y over dx squared is greater than 0, it is a minimum point. If d2y over dx squared is less than 0, it is a maximum point. And of course, if d2y over dx squared equals to 0, please take note it is inconclusive. That's what makes this second derivative test sucky. Okay, the limitation of it is if it's equals to 0, there's nothing you can do about it, but we got to go back to the first derivative test. Okay, so before we continue to apply whatever we learned from the previous session on more contextual word problems today, can I please invite everyone to take out all the relevant items? By now, you should have all these items on your table, but if you don't have, I'm going to give you 10 seconds to quickly take them out. Your A-Math textbook, A-Math exercise book, and also your writing materials. The countdown starts now. 5, 4, 3, 2, 1. All right, so ladies and gentlemen, you should have your materials with you, and we shall commence with the lesson now. All right, so for the next part of this lesson, can I invite everyone to turn to your textbook? Can you please turn to page 411? And in particular, I'd like you guys to have a look at try 8. Page 411, try 8. Okay, so let's have a look at try it now. You have two positive numbers, x and y, and you're given this equation, xy equals to 20 and z equals to x plus y over 5. So all of a sudden, you're supposed to show that x is equals to x plus 4 over x. Sorry, you're supposed to show that z is equals to x plus 4 over x. So if you look at this too carefully, ladies and gentlemen, what do you realize? Originally, I'm given z equals to x plus y over 5. And now all of a sudden, I'm supposed to show that z is purely in terms of x. Now, how can I go about doing that? Actually, we have come across a similar question like this before. So I'm going to give you guys a quick 3 minutes, okay, to attempt this question. Relief teacher, can I please invite you to pause the video now so that our students can have the next 3 minutes to attempt part 1. And your 3 minutes starts now. Okay, so I hope that you guys more or less have a head start on how to go about doing this question. So first of all, basically what we should conclude is that you notice from having a y in z to no y in z, that means to say we need to express y in terms, sorry, in terms of x. So that's what we need to do. So given that xy is equals to 20, to express y in terms of x, I know that y is equals to 20 over x. Right, so I call this equation number 1. And I'm given that I'm given that z is equals to x plus y over 5. Now I'm going to call this equation number 2 here. So what I've just done is this. I know I have expressed y in terms of x, so I will sub equation 1 into 2. So therefore you should have, sorry, why do I keep writing z today? Writing y today. Sorry about that. So z is equals to x plus 20 over x over 5. Then we go on to simplify. You should have x plus 20 over 5x, and that should reduce to x plus 4 over x, and therefore you have shown it. Yay. Okay, now let's have a quick look at part 2 now. We are supposed to calculate the value of x for which z has a stationary value. Okay, we'll go to the show part later on, but when we talk about stationary value, now does the key phrase stationary ring a bell? Yeah, that is something, that is a word that have been coming across pretty consistently in all the questions yesterday. So when we talk about stationary point, stationary value, we are talking about dy dx equals to 0. Yes, that's what we loosely would use, but that's because we are usually given y in terms of x. But in this case now, we are given z in terms of x here. Z equals to x plus 4 over x. So when they say that z has a stationary value, actually in the context of this question, it is saying that dz over dx is equals to 0. Okay, so before I go on to differentiate z, I would prefer to express this in index form so that it's easier for me to differentiate. And therefore dz over dx is equals to 1 plus 4 times negative 1 times x to the power negative 2. So this is 4 plus, or rather, sorry, this is 4 minus 4, 1 minus 4 over x squared. And that is our dz over dx. And because it's stationary, I need to equate our dz over dx to 0. From here, it will allow me to solve for the value of x. X squared equals to 4, and therefore x is equals to 2 or negative 2. But before we continue, we have two answers here. I'm just wondering, should we reject any of them? What do you guys think? Now read the first line, maybe it gives us a hint. Yes, you are right, because right at the start of the question, it has already mentioned that x is positive. So in this case, I have to reject x equals to negative 2. Okay, but at this juncture, I'll just like to let everyone know that we have not completed part 2 yet, because there is a second part to part 2, and that says show that this value of x makes z a minimum. Now, if you can recall from our previous lesson, when I have a point that is minimum, when I have a value that is minimum, what does that mean? Okay, if we go by the first derivative test, of course, the shape of the tangent will reveal to us that it is a minimum point. And if I go by the second derivative test, our d2z over dx squared will be greater than 0. So when it says show that this value of x makes z a minimum, what the question wants us to show is that I need to show d2z over dx squared is greater than 0 at which particular value? At x equals to 2. Okay, so this is what is required of us in case you haven't realized. Okay, I'm going by the second derivative test approach. So therefore, I need to go and find out what is d2z over dx squared first. And in this case, this is equals to minus 4 times negative 2 times x to the power of negative 3. and that should give us 8 over x cubed. So at x equals to 2, my d2z over dx squared is simply 8 over 2 cubed, which is equals to 1, and that makes it greater than 0. Alright, so ladies and gentlemen, at x equals to 2, alright, or rather since our dear d2z over dx squared is greater than 0, at x equals to 2, z is a minimum. Okay, so this is how we show that z is a minimum by the second derivative test approach. So before I continue, in case some of you were wondering, can I use the first derivative test approach to show? Of course you can. So instead of finding your d2z over dx squared, what you guys can do is you can go on to construct your table and of course make use of the x value, that is x equals to 2, and then you make use of 2 minus and 2 plus to go and determine the shape of your tangent line, and it should reveal to you that you have these shapes over here. That means to say it is a minimum point in this case. Okay, so but I won't show that in the interest of time. I'll leave it up to you guys to go back and try on your own. If you would like to try it, please go ahead and you may clarify with me again when I see you guys next Monday. Yeah. Okay, so at this juncture, can I invite the relief teacher to just pause the video for a short while so that our students can quickly jot down what has been shared before I move on to the next question. Thank you. Okay, so before I move on to the next question, which is try 9, that is found on page 412, I just want to do a very quick recap with everyone here. So ladies and gentlemen, suppose I have a triangle here. And then inside this triangle, I draw another smaller triangle. So therefore, I have A, B, C, D, E. Okay, and mind you, these two lines are parallel. So what I can say about this smaller triangle ABE and the entire big triangle ADE? I'm sure many of you would agree that triangle ABC and triangle ADE are similar. Now, since they are similar, that means to say the proportion of the sides are equal as well. So what do I mean? Suppose, for example, I call this BC as X and I call this entire thing as 20. Okay, and then if let's say I have this thing over here as Y and the entire triangle as 30, for example. Okay, so ladies and gentlemen, give you a quick 1 minute. Can you guys, or in fact less than that, a quick 30 seconds, can you form an equation involving x and y? And I'd like you guys to express y in terms of x. Can you guys please do so now? I'll give you guys a quick 30 seconds to do that. Relief teacher, you may pause this video so that our students can try it now. Thank you. Okay, so I suppose you guys should have come up with this equation over here, that is x over 20 is equals to y over 30, because when I compare the base of the small triangle to the base of the larger triangle, it is equals to the height of the smaller triangle over the height of the larger triangle. And from there, of course, I do a cross multiplication. I've successfully expressed y in terms of x. Okay, so let's bear in mind this important knowledge here and carry it with us as we attempt try 9 now. Okay, so as we look at this question over here, try 9, you have ABC with a height of 5 cm and a base of 12 cm. And then you also have a rectangle, which is shaded in green here, that is inscribed inside the triangle. The rectangle measures x by y cm. But of course, if I were to ask you point blank at this juncture, given that the length is x and the breadth is y, What can you say about the area of the rectangle? Okay, I'm sure many of us will agree that the area of the rectangle is simply just xy/cm square. Yes, you're not wrong to say that. But what does the question want us to show? The question wants us to show that the area of the rectangle is 5 over 12x times 12 minus x. Hey, wait a minute. If to compare these two, they don't quite look the same, do they? Okay, in fact, if you are observant enough, you realize that the variable y has disappeared. So what does that mean? Give you guys a quick pause to think about it. Yep, I think some of you would have concluded that there is a need for me to express y in terms of x. Okay, that means to say I need to form an equation involving both x and y, and thereafter express y in terms of x. But the key question is this: how can I go about doing that? Okay, I think I've dropped you guys enough subtle hint right at the start. Okay, maybe I want you guys to think along the line of a similar triangle, which is something that we have went through before this question. Okay, so just let me write down the thought process. I need to form an equation involving x and y. And in this case, probably you need to tap on your knowledge of similar triangle. Okay, look carefully at the figure. Do you spot any pair of similar triangles here? Okay, I give you guys about 5 minutes to try this now. Okay, go and form an equation involving x and y. Thereafter, you need to express y in terms of x. Okay, I think I've stated it over here. And with y in terms of x, make use of the area xy here and see whether you can express a solely in terms of x. Alright, really teacher, can I trouble you to pause the video now so that our students can try the question? Thank you. Okay, so this is where I'm going to go through the question now. So I hope you guys are able to spot a pair of similar triangles. In fact, I'm looking at the small triangle ADE and the larger triangle here that is ABC. Okay, if that is the case, since both ADE and ABC are similar, that means the proportion of the sides are equal as well. In other words, if I'm comparing the smaller base DE, the corresponding side here will be BC. And if I'm comparing the heights, it will be AD from the smaller triangle, and the corresponding height to compare will be AB. Alright, so this is where I'm going to plug in the values. DE, according to the question, is X, and BC is 12. AD in this case, please take note, many of us may be tempted to think that AD is Y, but actually, in actual fact, Y is the length of BD over here. So to find AD is actually 5 minus Y. And AB is 12. Sorry, AB is not 12. AB is actually 5. My bad. Alright, so from here, I'm going to do some form of cross multiplication and express y in terms of x. So this is 5x equals to 60 minus 12y. So 12y is equals to 60 minus 5x. And y is equals to, divide by 12 throughout, I get 5 minus 5 over 12x. Okay, of course, we are only halfway done because please take note, our dear area is xy, and now that I have y in terms of x, I will replace y by my x terms, which is 5 minus 5 over 12x. You know, this may look pretty straightforward, but if you look carefully, there is a certain form that the questions want us to show. So if you look carefully, I'm looking at this expression, a equals to 5 over 12x bracket 12 minus x. If I do a quick comparison, I already have the x on the outside. Okay, so what is missing? 5 out of 12. So I will look at this. look at the numbers inside, and I will factorize out a 5 out of 12. But how will this affect the numbers inside the bracket? Okay, so if I take out a 5 out of 12, this will simply just be 1x. If I were to factorize out, that means I divide 5 by 5 out of 12. You may use your calculator to do that, but you should get 12 in this case. Right, so ladies and gentlemen, I have just successfully shown that A equal to 5 over 12 times x times 12 minus x. Alright, so can the relief teacher please pause the video for a short while just to allow students to jot this down. For those of you who are fast enough, you have completed part 1, can I invite you to try part 2 on your own now as well? Thank you. Okay, so let's have a look at part 2 now, people. When you are asked to calculate the value of x for which A has a stationary value over here. So as we have discussed earlier on, when we say that A has a stationary value, that means to say dA over dx has to be equals to 0. That will allow us to find the value of x. Okay, so let's go back to A, which is 5 over 12x times 12 minus x. Okay, it makes sense for us to just consider this instead of A equals to xy. For a very simple reason, because we want to find out dA over dx. Alright, now before I were to differentiate A, I would prefer to expand this. Okay, some of you might want to differentiate this straight away through the use of product rule, but I thought this is pretty straightforward to expand. So I would have 5x minus 5x squared over 12. So from here, when I differentiate, with respect to x, I should get 5 minus 5 over 12 times 2x. Simplify, I should get 5 minus 5 over 6x. Okay, not to worry if you have used our product rule, we should end up with the same answer as well. Okay, so please take note, stationary value, I'm sure you guys are familiar with this. That means my dA dx is equals to 0. Go on to solve the value of x, and that should lead us to x equals to 6. And the next part is show that this value makes A a maximum. Okay, we have not completed part 2 yet. We are supposed to show that A is a maximum. Okay, how do we know whether A is a maximum or minimum? Remember, it depends on whether d2A over dx squared is maximum or minimum. So what I need to show is that I need to show d2A over dx squared is greater than 0 in this case. So let's go on to differentiate our dA over dx, which will give us d2A over dx squared here. And you realize that it is just negative 5 over 6. Now, in fact, what is so special in this case is there is no x variable. So there is no need for me to sub in the value of x. Straight away here, this is a negative value, which is less than 0. Alright, so since d2A over dx squared is less than 0, A is a maximum. Alright, in fact, I'm going to tell you that A is always a maximum regardless of whatever value of x that we've gotten. For a very simple fact that d2A over dx squared is negative 5 out of 6 regardless of the value of x. And therefore, A will always be a maximum in this case, ladies and gentlemen. Alright, so I will give you guys some time to jot this down. Alright, can the relief teacher please pause this video for a short while? Thank you very much. Okay, so people, can you turn with me to page 413 and let's have a look at try 10. Try 10 would require everyone to refer to example 10, where the plan of the cardboard is given over there. But this time round, it will be a 12 by 12 cm cardboard. But before we continue with the question, I think the main important question that we need to ask is this. Now, if I were to fold the cardboard into this open box that I've shown you guys over here, the main important question is, what do you think are the dimensions of this box? What do you think will be the length of this box? What do you think will be the breadth of the box? And what do you think will be the height of the box? Okay, I give you guys a quick 30 seconds to think through this. You may discuss with your partners, and your time starts now. Relief teacher, can you please pause the video? Thank you. Okay, so I hope you guys should have realized that in order to get the breadth, I would end up with a 12 minus 2x for the length and also 12 minus 2x for the breadth. Okay, this requires some form of visualization, and the height of the cuboid of this box would actually be xcm. Okay, so from here, things becomes much simpler for us now in terms of expressing the volume in terms of x. Okay, so to answer part one, write an expression for the volume. V is simply just, oops, sorry for that. My pen is running on low battery. That means to say I need to speed up a bit here. This is 12 minus 2x times 12 minus 2x times x. Okay, this is essentially 12 minus 2x whole thing square. And if you look at the common factors, we have 2 as a common factor. Factorize out. Okay, so that should be, sorry, 2 squared times 6 minus x squared times x, and it will leave us with 4x times 36 minus 12x plus x squared. All right, that is the answer in your textbook as well. Before I continue, I would like to ask everyone, what do you think is the range of x values? Okay, give you guys a hint here. You're looking at a cuboid with a dimension of xcm and 12 minus 2x for the length and breadth. What do you guys think? All right, so if I want the box to have a certain thickness, because if the box has no height, it will just simply be a 2D image. So obviously, our x has to be greater than 0. And the next important thing is this, 12 minus 2x. It has to be greater than 0 as well. Okay, it is not possible for us to have a breadth that is 0 cm, and needless to say, it's not possible for us to have a breadth that is in a negative dimension. Okay, so 12 minus 2x has to be greater than 0, and if you were to solve your inequality here, it will be negative 12, and x in this case has to be less than 6. Alright, so please bear in mind this is the range of x values that we should get. So with that information for volume in terms of x and a range of x values, can I invite everyone now to attempt part 2? Alright, where you're supposed to calculate the value of x for which v has a stationary value. I'm sure you guys should be familiar with this. And needless to say, I'm sure you guys are familiar with how to show that v is a maximum. Okay, I'll give you guys another 5 minutes to try this question. Can you please do so now? Relief teacher, can I invite you to pause the video as well? Thank you. Okay, so ladies and gentlemen, I hope you guys have managed to solve the question. I'm going to go through it now. So before I go on to differentiate v, I would prefer to expand it. Of course, if I have used product rule, we should end up with the same answer. Right, so if I were to go on to differentiate v with respect to x, I should get 144 minus, oops, sorry, there's a bit of mistake here. Yep, 96x plus 12x squared. Okay, so to find the value of x, the stationary value of x, I would equate our dv over dx to 0. Before I go on to apply my cross method, or some of you may straight away apply the quadratic formula, please take note that 12, 96, and 144, they all do have a common factor, which is 12 in this case. So with a smaller values to deal with, this makes the cross method even easier. All right, so I should have x minus 6 and x minus 2. So this leaves us with x equals to 6 or 2. But wait a minute, we have two possible answers. Does that mean that we should use both answers? No, because if you can recall earlier on, we did agree that x has to be greater than 0, but strictly less than 6. In other words, we have to reject x equals to 6, okay, for reasons which I've explained earlier on. All right, so at x equals to 2, okay, what I need to do next is I need to show, okay, because the question wants us to show that this value of x makes v a maximum. Okay, I need to show that d2v over dx squared is less than 0 in order for it to be a maximum at x equals to 2. All right, so I hope you guys have set out to find your d2v over dx squared. Please mark your work accordingly. You should get negative 96 plus 24x. So at x equals to 2, d2v over dx squared is simply negative 96 plus 24 times 2, and that leaves us with negative 48, which is less than 0. Therefore, since d2v over dx squared is less than 0, by the second derivative test, this means that v is a maximum at x equals to 2. And that's how we show it. Okay, so ladies and gentlemen, this is actually the last example which we will be going through together as a class. All right, with the remaining time that you have, I'll let you guys to put into practice what we have learned today. If you notice, if you realize actually this section that we have just learned today is not difficult at all. The only thing that is slightly more challenging is, for example, try 9, where you are supposed to express y in terms of x first before you can go on to express the area in terms of x. Okay, so these are the questions that I'll like you guys to try with the remaining time in class. And if you can't finish, you may bring back and finish it up over the weekend and submit to me on Monday. Okay, so please, with the remaining time, can you guys try exercise 16.2, question 8, 11, and 16 on the foolscap paper? If you can't finish it in class, it's fine. Please finish it over the weekend and submit to me on Monday. Of course, don't forget to revise for your WA1 as well, which is going to happen next Wednesday. And I'm sure that at this juncture, many of us are pretty concerned about the revision for chapter 13 on trigonometry. I've in fact given you guys some questions to try from the textbook earlier on Monday. So what's going to happen is this: I'm going to upload some of the explanations and solutions onto YouTube as well. That will come in due time by the end of this week. So I will submit, I will share the link with some of you, and please share the explanation of the solutions to the trigo questions via YouTube to with all your classmates as well. Yeah. What's gonna happen on Friday is this: I'll be getting you guys to try past year WA1 papers, which will be testing you guys on differentiation and also include some trigonometry questions for further practice as well. So for tomorrow, I'll need you guys you can continue to bring your textbook and your A-math exercise book, and of course your writing materials. You'll be trying those WA1 practice questions. Yep, so that is all from me. I'll see you guys soon. I'll see you guys on Monday. And thank you so much to the relief teacher for pausing the videos at suitable junctures. Thank you, everyone. Have a good weekend ahead. See you guys. Goodbye.